Hi everyone, welcome back to the workshop. Today we are looking at the Atezr P20 Plus. This is a diode laser that was sent to us for review. We're excited to get this one because it is one of the more powerful ones we've been able to look at. And we are going to see what that power does for us. Does it increase our working speed? Does it allow us to cut things deeper? And with that, does it still allow us to do some engraving details? So if this is something you're looking at and you want to see what I get up to with it, stay tuned. We're going to jump right into it. All right, so as I mentioned, this is the Atezr P20 Plus. This machine was sent to us for review. They're not paying us for any of this content. They just provided the machine for review. So we are going to look into it. So real briefly, let's look at some of the advertised specs of this machine. This is their P20 machine is rated at 24 watts of optical power. They kind of state it as 20 to 24. Now that does come down to a focus point of 0.08 by 0.06 millimeters. That is a finer point that we see with some of these higher power lasers, so it'll be interesting to see how that translates into its cutting power and engraving quality. One of the nice features of this laser is it is actually a 430 millimeter by 430 millimeter working area, so that is about 16.9 inches square. A lot of times when you get these 20 watt modules, they're actually taking up some of the existing framework of the 400 by 400, so it's nice to see that extra area still usable to us with this laser. It does create a bit larger frame. We'll address that a little bit later in the video as well. This machine does come with limit switches. As we're starting to see, that becomes a pretty standard equipment on these lasers, but they are nice for both safety and repeatability. So one of the nice things is it does include an air assist pump along with an integrated air assist cone that's on the end of the laser module. The air assist is variable speed. It shares the power cable with the laser. So you have fewer cables and such, and that variable speed is rated to be between 10 and 30 liters per minute. So getting that 30 liter per minute airflow is really great when cutting, but being able to dial it back when just doing engraving to keep a little positive airflow to keep that smoke and debris away from the lens, it's a really nice feature to have. So we're going to see how well that works. It does include a touchscreen offline controller. You'll see these on other modules such as Atom Stack. It's hooked up via a cable, sticks off the front of the machine, allows you some basic functionality through loading files through a TF card or a compact flash card into the module, and then some basic functions on the front of the screen. This is Lightburn compatible. That is an add-on expense that you would need to pay. It's not that much. It start out at $60 for your first year. After that, if you'd like to continue support, it's an additional $30 a year. It is also compatible with Laser GRBL, which is a free open source software that you can download and use with it as well. So there's also a Wi-Fi feature on here that you can use through an app on your phone. I'm not sure we're going to dive into that in this video, but it is a function and feature that is available on this laser as well. So with our features out of the way, let's talk a little bit about the build. I'm not going to do a full in-depth build. There are other people that have done those videos, and I'll add links down below. My friend David at the Clack Shack did a nice one as far as the build and the setup, so I'm not going to repeat that. If you're interested in that, that content's out there. But I do want to just touch on a few things that I noticed. Overall, it does go together very well. They do include a really decent manual with a lot of photos and diagrams to walk you through the build process. They do separate the hardware into individual bags. They label them by step. That's something most lasers are coming with nowadays, so that makes it a lot easier to identify which part or which screws go into which parts. And I had no trouble lining things up. The frame itself is a very sturdy C-channel type construction. The items, the screws, holes and whatnot lined up well. The frame is very solid when it gets put together. This is one of the more hefty laser frames I've seen, which I like. It is still portable. You can still move it around if needed, but when in place, it is sturdy, it is heavy. It holds itself down. It's not going to be walking away on you. The one issue I run into a lot of times with these diode lasers and their open frame architecture is cable management. This one is no different. They've bundled them together, and they use kind of that snakeskin sleeve to keep the wires bundled together, but you do need to route them properly to kind of keep them out of the way. They do provide some decent plastic clips that allow you to run the cable and not a fixed fashion. These are kind of alternating C-clips that go onto the frame with double-sided tape, and then the cables kind of slide in both directions and they stay there pretty well. But if you need to move and replace the cables or service them, you're not having to clip off zip ties in too many locations. All right, let's talk safety. There's always a concern with these, with operating safely with them. They do provide a metal shroud around the bottom of the laser module that also has a kind of a mirrored laser protected shield that reduces the amount of transmission of that light. Then the metal shroud then of course is completely opaque and nothing is going to come through there. Now of course it's not all the way down to the surface of the material, that would give you problems. So there is the chance for light to escape. And so they do provide a pair of laser safety goggles. Now, this is my complaint with all diode laser manufacturers. They send out these kind of just green or yellow tinted glasses. There's no ratings on them. There's no markings to really show that they've been properly tested and rated for the laser. So if you don't have anything else, yes, they're probably going to add a layer of protection, but without knowing that they are rated for the proper wavelength and the proper optical density, you don't know how much protection they are actually adding. I strongly recommend that you find a pair that matches the wavelength, and this laser is a 455 nanometer wavelength, plus or minus about 5, and then you're looking for an optical density of generally 4 plus. So I'll leave a link down to some down below that I like. They actually fit over my prescription glasses. They have a few different frame styles, and so that's one thing to keep in mind. They do have an emergency stop button. This is great. I'd like to see this on all lasers. It hasn't been. It's right on top in front. You just hit that thing down. It should kill the laser. It should kill the movement. Everything's going to stop. So this is great. If you're having an issue, it at least stops the laser from making it worse. The thing I don't like about it is that those cables are right next to it. They can kind of get into the way, and then you are going to have a chance of trying to hit that, and you're going to hit the cables and maybe have an issue. I'd love to see those cables maybe off the side of that module instead of right on top, but just kind of watch where you're running your cables, routing them. Keep them away from that e-stop button so that's available to you if you need it. All right, the first thing I do when testing a laser is to run material tests, and here we are cutting some 1/4 inch plywood. Now, once the cut was finished, we did kind of get some inconsistencies in the cut. That was more due to just the material being used, but as you can see there, we're getting 600 to 650 millimeters a minute for clean cuts in a single pass on this. And so then I went ahead and ran it on some 1/4 inch maple solid wood. And on the left, you will see that we have a grid pattern that nothing fell out on. So I went ahead and ran it, just doubling up to 2 passes over one. We were getting some clean cuts. Again, this was around 550 and 100% power with 2 passes, still getting through that material nice and cleanly. All right, so now that we have some of our basic tests done, what I want to do is test the power of how well it can cut various thicknesses and types of solid woods. So we're going to be working, we've got some maple and some poplar, some pine, and I believe I even have a few pieces of oak and such. I'm going to run a few of them through here. We're going to use a sample test shape that will cut both right angles, triangles, rounded shapes. It'll give us a better feel overall for its cutting ability on those. We'll see just how many it can get through as far as various thicknesses and various types of wood. So let's jump into that testing now and see how it performs. All right, we are going to start out with something fairly simple. This should be roughly 1/4 inch poplar, as you see there, or as it's just over 6 millimeters. And so what I'm going to do is I'm going to have it elevated on these rails so that we can clearly see when the material drops, and we'll have plenty of clean cuts through. So I'm just going to do this. We're going to set our focus. We'll be running full air on these, and I'm going to turn the exhaust on as well. Turn our air on, and we will start at 250 millimeters a minute, single pass, 100% power. Let's go. This looks like it's cutting through no problem, but we'll see in just a minute. Right, so yeah, that clearly dropped out, and pretty clean cut. So we can probably speed this up just a bit. So let's reframe it and add a little speed to it. Let's slide this forward so we get it in a fresh area. It's right there. And we will bump this up. Let's go up to 350 millimeters a minute, 100% power. And it did. Once again, clean cut, very little charring. Went right through. So let's flip this over, speed it up again. Just kind of get an idea what our top limit's going to be. So we're going to go 450. Make sure we're in a good spot. Looks like we are. 450 millimeters a minute, 100% power. All right, that one did not drop. Went through on the sides a little bit. So 450 is a little too much. Let's back it off to 400, see if it does it there. All right, we're in a good spot. So let's hit start. Seeing a lot of smoke underneath, so that's a good sign. But let's just wait and see what comes through. Oh. So it's there, it's almost through. So it looks like our last cut that was 350 millimeters a minute was probably our top speed for poplar at 1/4 inch. So let's try another material. All right, so this is a piece of maple. It's more hard maple. Again, it is 6.12 millimeters, basically a 1/4 inch. So we're dealing with the same thickness, but it is a little more dense material. So I'm going to back this down to 300 millimeters a minute, 100% power. It's not quite on there. Let's slide this over. All right, and let's run this. So I'm just doing single pass tests here. If you wanted to keep the speed up and do multiple passes, likely you'd be able to get through these as well. But I just want to see in single pass power what this laser is able to do at various speeds. So again, this is 300 millimeters a minute, 100% power. This is the top edge, backside, just almost, just holding on there. So let's just back it off a little bit. Again, this is hard maple compared to poplar, which did cut through at 350. I'm gonna back this down to 275 millimeters a minute, 100% power. Let's slide this up a little more. And there we go. Let's see if this cuts all the way through on this one. And this is an example of why even the same thickness material, but different types of wood, different, whether it's hardwood, softwood, or maybe solid wood versus plywood, you really need to run your material tests on each one, because in this example, we're seeing that the same thickness of material is not cutting through on maple when it did on poplar. And again, it did not drop out, but it did press out. So that is about what you're looking for. Like I said, it was just hanging on by friction alone. It felt like nice tight fit. So that was 275 millimeters a minute versus the 350 that cut out on poplar. So let's step it up to a thicker material. All right, so I've set the focus already, but let's just check the thickness of this. So this is, again, some poplar wood, and we are looking at about 12.95 millimeters. So we are just over half an inch, 13.10 millimeter. And I've set the focus to the top. Now, when cutting through material, you actually want to maybe lower your focus towards the middle, but just for the sake of keeping it consistent, we're going to keep it with having this focus. So our bar here is just touching the top of our material. Let's go ahead and make sure we're framed in okay. And let's go ahead and hit the start button. So I'm going to drop this down to 200 millimeters a minute, 100% power, and we'll see what it does. I'm not really expecting this to go through, but it is poplar, you never know. Yeah, like there, I think we're just getting some of the light, not quite getting through it all the whole way. So all right, did not drop out. That's the front side. Here's the back. So it's just with the grain, you're seeing it. So let's go ahead and slow this down. I'm going to drop it down to 125 millimeters a minute, staying at 100% power. Let's go ahead and reframe this. Actually, bring this over a little closer. And we'll rerun it. See if we can get through a one pass with the focus on top. I wouldn't want to go much slower than this at 100 millimeters a minute. At this point, I would start adding passes if this does not cut through. But let's see what it does. See how clean the cut it is if it does drop. And make some judgment calls from there. All right, looks like it did drop out. And just trying to make sure this is in focus. Fairly clean. There's not a lot of extra charring. So this 1/2-inch poplar at 125 millimeters a minute, definitely an option. All right, I have a piece of, this should be roughly 3/4 inch pine. So we're at just under 19 millimeters, just a hair under 3/4 of an inch. So about as close to 3/4 of an inch we're going to get. It's a little beat up on it, but that's fine. That shouldn't affect our test here. So once again, I am going to refocus this. I'm going to raise this up, bring our material underneath it, drop our foot down. Snug that up. So we're going to be going from the top focus, and I'm going to bump this one down to 100 millimeters a minute. Basically the slowest I would want to run it. So just make sure we're in frame. Looks good. We got the air on. Let's start running our test. Okay, there's the view from the top. Absolutely nothing through on the bottom. But let's flip this over. We've got that out of the way. Let's reframe this. Okay, we're on a good spot. As a matter of fact, I'm going to bring it over like that. And what I'm going to do is I'm actually going to speed this up to about 150. And I'm going to take it up to 3 passes because I didn't like how slow it was going, and want to give it some extra passes. So 150 millimeters a minute, 100% power, 3 passes. We'll see how this does. We're on pass 1, and we'll just watch the cut and see how it goes. A little fire underneath the bottom now. That is not a good thing. I'll blow it out. If it was any more than that, I would have had to stop this. And it's out of there. It did not drop out, but let's take a look. Okay, so here's the top, here's the back. You can see where that fire was, and it's just, I can maybe push this out, but it's just holding on that grain. Again, I wouldn't want to go many more passes. We were already getting some of that burning. And that's where you start to hit the limits on this thickness of wood. Maybe if it was poplar, it would get through it, but you know, I would say 1/2 inch is going to be our limit. All right, we've done some of this thinner plywood, but now that we found kind of like 1/2 inch plywood or hardwood was our limit with solid wood. Here I have, it's a little under 1/2 inch. It's 0.47 and in 12, well, basically 12 millimeter thickness plywood. Let's run this on that same test. So I'm going to set this down in here. Let's frame this up and refocus it. Bring this over a little bit more. Drop our foot down. that. All right, I'm going to turn the air back on. We're going to run this. We'll start at, let's see here. Well, our poplar was 125 millimeters a minute, so let's go at 100 for plywood. Like I say, that's about the slowest I'd want to run it. Frame it again, just double check. Looks good, and let's go ahead and start the job. So we've got the air on. We're running 100 millimeters a minute, and we're running 100% power. Oh, you know what? I left it on the multiple passes. So we're going to get 3 passes out of this. It did not drop on the first one. So let's just go ahead and let it run. And we're finishing up pass number 2. Yeah, I think I'm still seeing some flames every so often underneath. Definitely am. Did not drop. Starting pass number 3. I'm seeing actually some smoldering in there as well. So again, struggling with these extra layers and probably some of that glue. I think this would be a case to speed it up and do more passes to help eliminate some of that smoldering. As a matter of fact, I think I'm going to turn this off because I'm seeing way too much. So we're going to stop this. Move the head out of the way. Yep. There we go. See, we've got, that is why this is not a good idea to go that slow. So we're going to clean this up and check some things. Okay, so after that little slight disaster, what I'm going to do is adjust a couple things to see if we can actually get through this more reasonably. So right now it is set up with the focus basically right at the top of the material. So if I was to run this now, the beam is focused on top. Now there's not a lot of gap here, but what we can do is actually lower this down a little bit to get our focal point even lower. So what I like to do is just leave this a little bit loose. We're going to loosen up the head and we're going to drop this down just so that it's still above there. We'll tighten it back up and that will move the focus point down just a little bit deeper into the wood, which should give us a little more effective cut. The other thing I'm going to do is I'm going to speed it up quite a bit and we'll add extra passes. Let's adjust our cut layers to, we're going to go up to 450 millimeters a minute. And let's take it up to 6 passes. We've got our air on, we've got it framed up. Let's give it a shot. So we're going to hit start. We also have our focus lower. Now you see it's moving much faster than we were before. That beam isn't lingering in one spot. It won't be superheating that wood. It's going to make multiple passes, so hopefully get through. So let's just let this run and see if this works a little bit better than before. Already I'm starting to see smoke come out the back on bottom, so that's a good sign. Just on second pass, our lower focus may have helped that. Hasn't dropped through yet, but the beam is moving through there, hopefully not lingering in any spot too long. This is pass number 4. Hasn't dropped out, but pass number 5. Oh, it just dropped. So 5 passes did it. We'll let it finish this 6th. Just because I don't want to interrupt it. But we'll rerun this one more time with a couple more tweaks. Okay, so here you see, it got through. It's not terrible. There's a little extra charring. And some of that could be from our beam going through, but not bad. Far better than the charred mess we got. But you see on the back side, at least on the inside part where we cut this out, we are getting a little bit of a lot of charring. So, all right, so we ran our tests on a variety of wood. You know, the softer hardwoods like poplar, definitely in 1/4 inch and 1/2 inch. Getting through that just fine. Even 1/4 inch maple seemed to do pretty well. Did have to slow it down a bit for that though. But then, you know, even on the soft 3/4 inch pine, we just struggled to get through. There may be, you know, trying to bring that focus down a little bit, adding some passes, you might be able to get through this as well. But at the speeds you're going and the amount of back charring you're going to get on the bottom side of this, I just don't know that it's going to be really feasible for, you know, fairly clean cuts. Same thing with plywood. You know, we cut the 1/2 inch plywood, and that edge, just the top part's okay, but this back part just really ended up really charred. And so, yeah, you can do it, but I think, you know, it's maybe not the best tool for that. So, you know, take that into consideration. So a lot of times when you get into these higher wattage of 20, 24 watts and on up, people are always interested in like how thick of a material it can cut, and that's great, but you know, you have diminishing returns in the fact that you can't really adjust that focal depth too far, and so it's more about improving your speed of materials you can cut with maybe a small increase in the depth of the cut. But then there's also the question of, can they still engrave? So I did run a material test on engraving, and as you can see here, down at the bottom, we have the 1500 millimeters a minute, and at 100% power, we went all the way through. But up at the top here, 7500 millimeters a minute and 100% power is okay, but you're really not getting anything down here in the 10%. So where I found to be a good sweet spot is 5500 to 6500 millimeters a minute, and then from 10 to 100% power. So knowing those numbers, we can start dialing it in, at least on wood. So I went ahead and did a 3D engraving. This is from a file we found online in one of the groups. It's kind of a 3D relief engraving of a bee. And you know, the grayscale effect is very pretty well. This was run at 6500 millimeters a minute, 100% power. And I believe it was with Atkinson dithering. And so definitely some detail there in that. And then we also ran our favorite, some slate tile. I did actually play around with putting some finish on this one. I haven't so much in the past because I'm not sure I like that kind of slight shiny effect, but it really does add some contrast. It darkens up the tile, makes the whites brighter. So as far as the speeds and settings on here, this was 5000 millimeters a minute, 60% max power. And like I said, I sealed it with a satin clear coat, which really helped bring out the contrast of the material. It just does add a little bit of a sheen to it, but still, you know, this looks pretty good. Yeah, you might get better detail out of a 5-watt laser, but for your average person that's not necessarily going to know the difference between that, I think they're going to be happy with this. So, you know, as far as engraving, yes, you still have the capability of doing that with this machine. All right, we went through a lot of different operations on this laser. We tested cutting, we tested engraving, and a few different materials. And as you could see from my results, we had a lot of decent success with it. Will the higher wattage diode laser let you cut through really thick material? Yes and no. It will get through thicker material. However, I don't think it's quite efficient, and it does tend to leave a little more of a messy cut on the bottom of those. On thinner materials that you might be used to cutting with, you know, a 10-watt diode laser or even a 5-watt, it's going to cut through those much faster and cleaner. Really appreciate the air assist and the combination of that with the variable power that you can do with this laser to really fine-tune your speed and your quality. Some of my concerns about this laser would be, as I mentioned earlier, those cables sticking out of the top of the module. I really wish they were off to the side, and that would get them out of the way. This would be both for just a functionality thing, but it also allows easier access to that e-stop button. So another thing is, it's great that this is a bigger laser, that it allows that full 430 by 430 millimeter square frame of working area. However, that does mean that it is over about 28 inches square both directions. And the enclosures that are on the market today that maybe you've built or that you've bought already, it's not going to fit in them very well. They do offer their own enclosure that you might want to look at. Otherwise, you're going to have to build your own, make it a little bit bigger, or wait for the market to catch up if you're looking for more aftermarket options on this. Now, the shroud on the end of the laser is great from added protection. However, it does make it hard to see the laser point as you're trying to frame your object. There's no offset laser to do your framing, so you really want to use the power on feature, low power framing with the laser. However, with just that small front window and then the opaque metal around the outsides. It does add a little bit of complexity in framing. And the addition of the offline controller is nice. However, I do not find myself using it a lot. As a matter of fact, I disconnect it and leave it out just to make it easier to fit into the enclosures and not be in the way. Let's talk about what I really did like about this laser. This is a very solid frame. This machine, once you have it together, is very tight. It's very heavy. It sits in place well, and it's not going to go anywhere. I like that it is really solid T-channel type construction to lock it together, and I feel like you could sit on this thing and it's not going to bend or flex. So props to them on really not underdeveloping this frame, making it very beefy for what it's going to do. Even with that heavy frame, it does still move around very quickly. The white space scanning movements were very fast, very precise, and so this frame and the movements of the machine, really impressed with that. On top of that, for a higher power laser in the 20 to 24 watt diode range, the fine focus point did seem to actually be an improvement over others. It's slightly rectangular, but at that 0.08 by 0.06, I don't think you're going to notice a big deal there. You may want to do a curve test just to get that dialed in a little bit closer. And I've done a video on that. You might want to check it out. I'll link it down below. I really appreciated the flip down foot on the side of the laser for focusing. Some of the other lasers, they give you a piece of acrylic or they give you a piece of metal that is your focal distance that you put underneath the module. And too often than not, those walk away. This is on the module. It's going to stay there. You can't lose it. And so it's great to have that included right there. I really liked the air pump on this laser. The variable speed worked well. The fact that the cables were split and joined with the power supply, it's one less plug that I got to worry about. And it did seem to perform well. Usually I would have to turn the knob up to about half to get just a light airflow for engraving, and then crank it all the way up for cutting, and you're getting that full 30 liters a minute. So would I recommend this laser? Now, I don't often say whether I will recommend lasers or not, but this one did impress me. I think it's right up there with the other 20 watt lasers, and in some ways surpassing them. Like I said, I'm very impressed with this frame. It's a very solid frame, very beefy frame, and I think overall there's a lot of thought that went into this laser. And so I think from a maintenance standpoint, from a quality standpoint, from what my tests showed as far as its capabilities and its output, this is a big win. And at the time of this recording, this laser is going for about $1,000. There are some coupons going on for it right now. Its normal street price is $12.99 US dollars, but oftentimes you can find deals. And so I will have links down below to where you can purchase this, along with some of the accessories and some of the other items that I have used with mine. And so I would appreciate any chance you can get to using those links if I helped you make that decision. Yes, I think I would recommend this laser to someone looking into getting into a 20 watt diode laser. There's, as far as its features and functionalities, I think the price point balanced with the features you do get with it, this really hits a lot of the points and puts it above a lot of the others. So that's going to wrap it up for this video. I hope this was some good information on this laser. If it's something you're looking at or just curious about what the performance is, if you have any questions or comments, go ahead and leave them down below. And if you'd like to continue to follow with what I'm doing in my workshop, go ahead and hit that subscribe button. I really appreciate it. I hope you enjoyed this video. Thanks for sticking out with it to the end. I will be doing more with this laser, more projects. We will be doing other reviews down the road. So I hope to see you in the future. And in the meantime, I hope you can get out into your workshop and make something too. We'll catch you next time.